Okay, folks, it's time to jump into some more information, but now is really the transition into the part of class where we start talking more about drugs. So how do drugs work on proteins? We'll do an overview now so that when we jump into all of our specific examples, we have a better idea of what's happening. Many drugs work by blocking the normal function of a protein. So both of these words, antagonist and inhibitor, means they stop the protein from working. And this is the majority of drugs out there. The vast majority of drugs out there will go and stop something from happening. That's not always true. However, some drugs actually turn the protein on. They make the protein work. And so we call those agonists or activators. And these make the protein work. So let's walk through our various examples of proteins, receptors, signaling events, and enzymes, and think about how a drug might affect each of those proteins differently. As a quick refresher, folks, this is a receptor. So what we saw was a series of events. A ligand came in to bind, it turned the receptor on, and then the receptor was like, hey cell, I've been turned on. How might a drug impact this? Well, in comes the drug. You'll notice that the drug has a shape very similar to the ligand. Oops, that's not how you spell. And because the drug looks so much like the ligand, the drug is able to match the shape and go bind to the receptor. However, since the drug is not the ligand, the drug does not turn the receptor on. So this other little thing that was going to come in and bind here can't. You see, there's no room for it to bind. There's no little square that's been opened up. So it's too bad, so sad. Blocked. That's what happens with something like a receptor. What about a signaling protein? Well, recall here that the signaling protein can come in after the ligand has bound, and then once that signaling protein is kind of turned on, it creates this cascade of events that happens. Maybe this next protein gets turned on, and then the next, and then the next, etc. Well, here, the drug's purpose is going to be to block the signaling event. So for example, let's say this first signaling protein can still come in and gets turned on. But when this next signaling protein goes to turn on another signaling protein, the drug swoops in and grabs it up. Since that drug has now grabbed up that other signaling protein, the next step is not going to happen because the drug blocked one of the signaling events. So that's oftentimes how a drug can act on a signaling protein, is it blocks this kind of sequence of events that can sometimes happen. Lastly, folks, how can drugs work on enzymes? Well, we saw that this enzyme bound to the thing that it likes to grab onto, performs some chemistry on it, and then we end up with this very different looking product. How might a drug impact that? Well, folks, what can happen is oftentimes these enzymes can bind both the substrate and the drug. But when the drug binds, it kind of stops that reaction from happening. The drug changes the enzyme in some way so that it can't do chemistry. So no reaction is allowed to take place. And so that's how many drugs work, folks. Over the next few weeks, especially as we jump into various case studies of drugs, first up is cannabis, we will see examples of the things we just learned today. To review, we learned that proteins have a wide variety of functions. We also learned that proteins are the primary target of drugs, and we learned some different ways that drugs stop proteins from doing their work. Of course, drugs can also turn proteins on. So we'll just keep that in mind. With that, I'll leave you with this cat meme. See you in class.